Elastic versus inelastic collisions. The law of conservation of energy says that energy cannot be created or destroyed. It can only change from one form to another. In some collisions, some kinetic energy is transferred to another form of energy. Take two cars of the same mass colliding, for example. Before the collision, each car has a given value for its kinetic energy. After the collision, both cars are damaged and each has a kinetic energy that is less than its initial kinetic energy. Their kinetic energy was transferred to other forms of energy. For example, friction can turn kinetic energy into heat. Remember that kinetic energy is only conserved in a system if the work done by non-conservative external forces is equal to zero. In our car crash, the work done by non-conservative external forces, such as friction, was not equal to zero, so kinetic energy itself was not conserved. The energy was transferred to another form. We classify collisions as elastic or inelastic, depending on whether the total kinetic energy of the system changes during the collision. In an elastic collision, the total kinetic energy of the system does not change during the collision. An example of an elastic collision would be a ball that could reach the same height it was dropped from after colliding with the floor. In this case, the total kinetic energy of the ball before the collision is the same after the collision. In an inelastic collision, the total kinetic energy of the system changes during the collision. A basketball that is not completely full, for example, will not reach the height it was dropped from if it is bounced. Its kinetic energy is not conserved during the collision. Our example of cars colliding earlier was also an example of an inelastic collision. We say that a collision is totally inelastic when objects stick together, like a very flat basketball that doesn't bounce at all. In this case, the maximum amount of kinetic energy is transferred to other forms of energy.